In this video, we're going to calculate a probability. Let's calculate the probability that x is less than or equal to 72. And to do this, we're not going to integrate anything. We're going to use Minitab, which gives us a very convenient way to calculate normal probabilities. So I've gone to Minitab, and we're going to look at probability distributions and the normal. We're going to check cumulative probability because remember we're looking for a less than or equal to. For the normal that we're playing with, we have a mean of 69.5, which I'll enter, and a standard deviation of 2.4, which I will enter. We're going to use an input constant. I want to know less than or equal to 72. So we'll enter 72. And this will be, remember, we've calculated cumulative probabilities before, but this will be everything up to and including 72. So we say OK, and the results are back. The probability that x is less than or equal to 72 is 0.8512, or about 85% of the males in the population will be less than or equal to 6 foot tall, 72 inches. Now here's another example. The Americans with Disabilities Act requires that when we build structures, that the walkways and the stairways and what they call circulation avenues all have a clearance of 80 inches, not 80 degrees, but 80 inches. This gives us headroom. The clearance gives us our headroom. We don't want to be bumping our heads. How adequate would 80 inches of headroom be? Well, let's calculate the probability that a randomly chosen male from the current U.S. population would be well served by 80 inches of headroom. That is, would have the probability of a randomly selected male being less than or equal to 80 inches. Calculate that probability, and that'll be the proportion in the population that would be well served by a headroom of less than or equal to 80 inches. So it's the probability x is less than or equal to 80. And to calculate that, once again, we'll use Minitab. And here we are in Minitab. We'll calculate probability distributions, a normal. The only thing that we'll have to change is our input constant because our mean and standard deviation hasn't changed and we're still looking for a less than or equal to, a cumulative distribution. So changing 72 to 80, I see that 99.99% of the population would be well served by a headroom of 80 inches. That's just to say 99.9% of the male population is less than 80 inches tall. And so, of course, we know then, since the females tend to be shorter, that the females, at least 99.9% of the females, would be just fine with 80 inches of headroom. Well, that wraps up these examples. Next video will be up in a moment.